All right, so the giggling's already begun. And 12.5 here, guys. Titled Proving Triangle Congruence by, this time, SSS. What do you guys think that stands for?
Side.
It's going to stand for side, side, side. Yeah, we're going to talk about 3 different sides. So it's going to stand for side, side, side. And we're trying to figure out today what can you conclude about 2 triangles when you know the corresponding sides are all congruent. All right? So goals for today. First one, Kylie, you want to read that?
Use side, 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 SSS congruency theorem.
Okay, use side, side, side congruency theorem. And then the next one here, McKenna, have you got that?
Use the hypotenuse leg HL congruence theorem.
Okay, hypotenuse leg. We've used that before. Those are always evident in what kind of a triangle?
Obtuse.
Not obtuse.
Right.
Right triangles.
Oh.
There you go. Right triangles. Good. So if I make a note up here, hypotenuse leg theorem that we're going to talk about today, that's only evident in right triangles. Guys, we can get away with using side, side, side in all triangles. So these 2 theorems we're going to discuss today, side, 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 and hypotenuse leg. Just know side, side, side could be used in any triangle, but hypotenuse leg theorem can only be used in what kind of a triangle? Right triangle. Okay, let's look at some terms here. So the first thing we got there are legs. You want to read that for me, Kylie?
The sides adjacent to the right angle of a right triangle.
All right, so if I had a right triangle in here, this is the sides adjacent to the right angle of the right triangle. So if this is my right angle right here, this here would be a leg, this here would be a leg. Okay, the 2 legs really form the right angle, don't they?
Mm-hmm.
Okay. And then what are you going to call the side opposite of that then? Hypotenuse. You've seen this before. We've talked about this before. So it's just terminology we're bringing back up, but we're going to look at it in a different context today. So if this was my right triangle right here, this here would be your hypotenuse. Longest side is always a hypotenuse. I'm going to make that note over here. This is always the longest side in a right triangle, which means the legs are the 2 shorter sides, right? And again, only talking about these as they exist in what types of triangles? Right triangles. Okay. All right, now we've got some other things up here, guys. We've talked about in the past, congruent figures. Congruent figures are geometric shapes that have the same size and the same shape. The thing that we're going to talk about with congruent figures today is this. Naming congruent figures correctly. All right, and I'll show you an example of that here in a bit. Naming congruent figures correctly. I'll show you what I mean by that here in a little bit. All right, we know what congruent figures are. We want to make sure we get into the habit of being able to identify the names of them correctly so that there's a thing called a, what's this phrase right here I'm pointing at? Rigid motion that would transform any shape onto another so that it preserves length and angle measure. We're trying to make sure that things match up today. Okay? Rigid motion. We'll look at a rigid motion to see how things match up today. Okay? So, vocab wise, you girls okay on that?
Mm-hmm.
Any questions so far? All right. It's pretty simple. Okay, so let's run into the core concept here. These 2 theorems that we talked about. First one's a side, side, side congruency theorem. All right, McKenna, you want to read that for me real quickly?
If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent.
All right, so let me give you an example. I'm going to try and sketch 2 triangles that are exactly the same up here. Let's do this. Why don't you guys do the same thing? Draw a triangle that maybe looks like this, and then try and draw the same exact one. I'll try and draw the same exact one if I can. How'd I do?
Pretty good.
Pretty darn good, right? Okay, what's the name of this theorem again, guys?
Side,
Side, side, side. I should highlight this. Hang on a second. Highlighter a little bigger. Side, side, side congruency theorem. Pretty important one here, okay? We said that triangles could be congruent in the last couple of sections that we had if we had two sides and an included angle. So we had side, angle, side, right?
Mm-hmm.
Well, this is different in this way right here, guys. Go ahead and label your triangles as follows. Call this A, call this B, call this C, and we'll call this one maybe, I don't know, U, H, and S. Okay? So guys, in the side angle side theorem, how many sides did they give you that were congruent most times? Two, and then you had also an included angle. So you knew two sides and you knew the angle. But in side, 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 what do you think the information you're going to need to have in order to prove that these two triangles are congruent? What do you think you're going to need to have?
Three sides.
3 sides. So here's the deal. If I would say, hey, put a tick mark through this side AB, where are you going to put one tick mark at in the other triangle? UH. Okay. If I put two tick marks through BC, where do you think the two tick marks are going to go here? And then finally, if I put 3 tick marks through AC, then, okay, so here's the deal. I would say that these two triangles are congruent to each other, but when I name them congruent to each other, we're going to say they're congruent by side, 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 but we've got to make sure the order's matched. So let me just give a name for this first triangle. What do you want to name this first triangle over here on the left?
ABC.
Okay, so take a look at the way you've ordered this right here. A to B is listed first and second. So this segment A to B up top here, how many tick marks in AB?
1.
1. So where's the 1 tick mark at up here? U and H. So do I label this UH or HU? It's got to go UH because the next one goes from B to C, and B to C has to be the 2 tick mark side. So as I follow the 1 tick mark from UH, I've got to go and follow the second tick mark, or the one with 2 tick marks, to H and S. So do you get the order on this and why they are labeled the way they are? Okay, so 2 triangles will be congruent if 3 sides of one triangle are congruent to 3 sides of a second triangle. And that theorem's called what again, guys?
Side, side, side.
Side, side, side. And we'll look at some examples with proof in that here in a bit. Okay? Questions first side, kiddos? No go? All right. Then let's look at this next one here. Hypotenuse leg theorem basically says this. Kylie, you want to read that for me?
If the hypotenuse,
Start over. Reset.
if the
Reset.
hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the 2 triangles are congruent.
Okay, specifically what types of triangles with this theorem, guys?
Right.
Right triangle. Okay? Right triangle. So let's get 2 right triangles sketched up there that look pretty much the same. Okay, so I'll do this. There are my 2 right triangles. Right here, exactly the same. Okay, it says in this right here, if they're a right triangle, I want to make sure I identify a right angle in this. Okay. I don't care what we call this, X, Y, Z maybe. And call this maybe J, K, L. Okay. So a hypotenuse and a leg, all right? Hypotenuse and a leg. Which side do I absolutely have to know up here if I'm going to have a hypotenuse in this first triangle?
X to Z.
X to Z. So I'm going to put a tick mark through XZ. So if I put a tick mark through XZ, I want that to match the hypotenuse on the other triangle. So what's that going to match there? JL, all right? Do you guys remember Pythagorean theorem? A squared plus B squared is equal to C squared?
Yeah.
Basically, hypotenuse leg theorem is a spin-off of that formula. A squared plus B squared is equal to C squared. A and B are the legs, C is the hypotenuse. Basically what it says is this. If you know one leg right here and you know the hypotenuse in a right triangle, can't you figure out the length of the other leg?
Yeah.
Well, if I put 2 tick marks over here at JK like I did over here for XY, if I just told you, hey, this distance maybe over here is 3 and this is 5, and then this distance would be congruent, 3 and 5. What's going to be true about the distance from YZ and KL if both of those are right triangles and we know both of them apply to the Pythagorean theorem? What's going to be true about this distance if I stick 3 and 5 into the formula in the same position each time? Aren't you going to get the same unknown distance out down here?
Yes.
Yeah.
Okay, so if you know the hypotenuse, do I have a pair of, or are the hypotenuses the same in this?
Yeah.
Yeah.
Are the legs the same in this?
Yes.
And I can use the hypotenuse leg theorem because this is what type of a triangle?
Right.
Right triangle. So by order up here, guys, I would say the following. I would say, you know what? In this triangle right here, we would say triangle XYZ is congruent to, you give me the order on the second one then. The way I've written. JKL. Yep, XYZ following around like that. JKL. It's got to match that order. All right. So side, side, side can be used with any triangle. Hypotenuse leg can only be used with a what? Right triangle. Okay. All right, so let's rock and roll on this. Let's see if we can apply these two theorems here with a little bit of proof. I think we've got about 3 or 4 examples. It's pretty easy. Pretty easy. All right, using the side, side, side congruence theorem. It says to write a proof. Help me with vertices. What's over here on the far left?
P,
P,
Q, R, S.
all right, and I believe there's some information that they give us. They say, first of all, given in is the distance from PQ is equal to the distance to RQ. So PQ and RQ. Did I put 1 tick mark in there or 2? Okay, so they're saying if PQ and RQ are equal, then boom, there's the tick mark. Okay. They also tell you that PS is equal to what?
RS.
So it'd be 2 different.
Okay. So we need to write a proof to show that the triangles here are congruent. So I'm going to highlight these. First one is triangle PQS, right guys?
Yes.
Triangle PQS right here in blue, congruent to triangle RQS over here on the right in red. Okay, anytime you've done a 2-column proof to show that 2 triangles are congruent right here, guys, we always start out with what? So here's my little T-chart for this. Statements. And the reason for it. So what's the first thing you want to say up here, girls?
PQ equals RQ.
PQ is equal to RQ. Now keep in mind, guys, up here in example 1, it says we're using which congruence theorem?
S.
So we're probably going to have 3 parts in here where we have 3 different pairs of sides equal, right? Okay, PQ is equal to RQ. How do you know that? It was given to you. Any others that were given to us in step 2?
PS equals RS.
I should probably say they're congruent, right? That was also what?
Given.
Given. And I'm going to back up on these first 2 givens right here. This here, they gave you a pair of sides congruent right there, didn't they?
Yeah.
Step 2, when they gave you those sets, PS and RS, right here and here. That was also giving you another what?
Side.
All right, so if side, side, side congruency theorem, how many of the 3 have you satisfied so far with the given part?
2.
So if I could find that third pair that's congruent,
Sweet.
QS equals QS.
QS is equal to QS, what's your reasoning?
Reflexive.
You bet.
Woo! Got it.
Yeah, QS and QS, same line. Oh my goodness. Well, we found out earlier in the notes on that core concept that said, hey, if you have 3 pairs of congruent sides in triangles, then the triangles are congruent. So what can I say about these 2 triangles then? PQS and RQS. So step 4, we'll say triangle PQS is congruent to triangle RQS. And what's the reasoning? SSS. We've shown to you all 3 pairs of sides are congruent. So by side, side, side congruency theorem, those triangles are congruent. Okay? You guys feel okay about that?
Yep.
Yeah.
How many pairs of sides are you showing congruent in side, side, side?
3.
Basically, you need to have the steps up here. Somewhere 3 steps, it gives you 1, 2, 3 pairs of sides congruent. Once you have that, your last step is to say, oh, the triangles are congruent by that. Very good. They're giving me a round of applause for that. Isn't that awesome? All right, next one here. Help me label.
S.
All right, I think there's a line right here, right?
Correct.
Okay, this is a pretty interesting problem right here. First of all, it says, it's not straight?
No.
You better get to the eye doctor because I think it looks very straight.
Nope.
Well, let me try again. I did the same thing last time. All right, here we go. Help me with this right here. What's down here?
R.
R, S, T, Q, and
R.
P, right?
R.
Well, we better make this a P. Change that to P down there, okay? Change that to a P. That's my mistake on notes. Okay?
Okay.
All right. Did I put some tick marks in this?
Yeah.
Yep.
R S R
Okay.
is 1, then S to T is 3, and then R to T is 2.
How about over here?
1.
Okay.
You have it. And
Same
then-
order?
Yeah.
Okay. Guys, up here in example 2, they're saying, I want you to determine if the congruent statements are true. Okay? Now, guys, they give you a drawing. First of all, are these triangles congruent, number 1?
Yeah.
They're, no matter what, you know they're congruent. How do you know?
Because it has side.
Side, side, side. What we're trying to determine right here is if the order in which they wrote triangle RST congruent to triangle TQP, they want to know if that's congruent right there. That's the part we're trying to determine if that statement is true or false based on a diagram. So here's what I'm going to tell you to do. Here's what I'm going to tell you to do. Take a look at your side right here. It's listed first. RS is listed first, right?
Right.
RS has how many tick marks?
1.
1. That should match the first and second one here of what?
Yeah.
Does that match?
Yeah.
Okay. Take a look at your second one right here. S to T has how many tick marks, guys? 3. Check the order that's listed second and third like ST was. QP, QP. Is QP right
Yeah.
here?
Yes.
That works, right?
Yeah.
And then finally T back to R. T back to R. Third one, first one. P back to T.
It's congruent.
Okay. So is this order right up here? Is that order up there okay or not okay?
True.
Okay.
That is okay. All right? It's okay because everything matches up. Now, the thing I want you to look at that could be confusing is this. First of all, in these triangles right here, help me with this. Is this A down here?
B.
B?
That was really loud.
A.
C. X.
X.
Oh,
X
that
is so
come from?
random.
And this is what?
C.
C.
Okay, 1 tick mark or 2?
1.
1 here, 1 here, and then 2 up here?
Yeah.
All right, first of all, are the triangles congruent? Don't even worry about the statement up top here, but are the
Yeah.
triangles congruent?
They are.
You have 2 pairs of sides congruent, but you also have a reflexive side. AC is shared with AC.
Correct.
So the triangles are going to be congruent. The question becomes this. Is the order with which this is written the same as this? So let's check this right up here. I'm going to do this. AB is listed first in the triangle down here, right, guys?
Right.
Yeah.
But what's listed first up here in the second triangle?
A. C.
They should have listed what
Um.
first?
X.
A.
Yeah, there's no way in this second triangle up here that this side is the same as AB, right?
Right.
Okay, what they should have listed was this side, and they didn't. The side that should have been listed first up here should have been X to what? X to C or what?
What was the question?
AB was listed first up here in this triangle, and that was this side. And it had to match the one with the 1 tick mark over here. So the order on this second triangle should have started out as either XC or what?
C.
Is that happening here?
No.
No.
So the question becomes this. I get that these triangles are congruent. They are still congruent. The question is this statement right up here true or false based on the order? Going to be false. Okay. So when you get a diagram, they're not necessarily saying, hey, are the triangles congruent or not? They're going to be congruent. They want to know if the order in which they wrote stuff to say this is congruent to this, they want to know if that order matches the diagram. That's what they're asking. Okay.
Alrighty.
Make sense?
Yep.
Okay. You guys okay with side, side, side?
Yep.
Yeah.
All right. Let's explore hypotenuse leg here a little bit. Using the hypotenuse leg congruence theorem. Okay, again, I need help here. This is only going to work in what?
Right angle. Or yeah.
Only works in a
Triangles.
right triangle. Only works in a right triangle. Okay, so down here, I need help with the labels down here. Where are P, Q, R, and S at?
Q by the first right angle.
Top left?
Yeah.
So this must be P.
PSR.
S?
Yep.
I think there's tick marks on the left side and right side, is that right?
Yep.
And
Alright.
this is good. We need to have a right angle. So do we have a couple of right triangles right there?
Yep.
Okay.
Gosh.
So again, two-column proof. To prove right here, what are we setting out to prove? Well, this is what I want to prove. Triangle. Go with it, McKenna.
Triangle PQR equals triangle RSP.
That's what we're trying to show right up here, okay? Trying to show that the top triangle is obviously equal to the bottom triangle. Now guys, as you look at this looks like a rectangle, doesn't it?
Yep.
And if I cut a rectangle diagonally in half, the two triangles should be congruent, okay? I'm recording this right now, Caitlin. Isn't that scary? Yeah, I know. All right, let's roll with this. Any little T-chart for a two-column proof every single time, what are you always going to start out with? What are you going to do? Given. So what's the first thing that's given?
PQ equals RS.
PQ equals? RS. Did I put statements up there?
No, I didn't.
Oh, beautiful. Now she's snorting. That's great. Welcome to the pig pen. Welcome to the pig pen. Statements and then reasons over here. Or did you call that razzing? Okay, what are you going to do for here, guys? What are you going to call this over here?
Given.
Given. It's given to you. Okay. So PQ is equal to RS.
And angle Q and angle S are right angles.
Okay, angle Q. So angle Q is going to equal or be congruent to angle S because that was given too, right?
Yes.
Correct.
Guys, quick question. PQ and RS, are they legs or are they PQ and RS? Are they legs or are they're all legs, right? So what I might say here is this. If I'm going to use the hypotenuse leg theorem, I need to show that I've got two sides that are equal legs, right?
Mm-hmm.
Yes.
Okay. Haven't I really kind of done that in this given part up here?
Yeah.
Okay. So I might write this again. Those are the given parts. Those are the legs. So that's good. Leave it that way. You already know like angle Q is equal to angle S because they're both what kind of angles, guys?
Right angles.
These are both right angles. Okay. So I'm going to write up here with this given part. This is really saying that you have equal legs. And angle Q and angle S were both what type of angles, guys?
Right.
So we have equal legs, and then the next thing I'm going to say about this is the following. If I'm using a hypotenuse leg theorem, you said you already have the equal legs, so it'd be good to get the equal hypotenuse in both triangles. Well, what is the hypotenuse segment in each of those triangles?
PR.
Okay, so right here, PR is going to equal, or be congruent to PR again, isn't it?
Oops. Yeah.
Because, what property? It's the same line. It's reflexive. But that reflexive property is really giving you this is really giving you the congruent hypotenuse in each triangle, isn't it?
Mm-hmm.
Yes.
So let's see. Do we have a right triangle?
Yes.
Both of them are right triangles. That's what step 2 told us, right?
Yes.
Do we have equal legs?
Yes.
Yeah.
That's really what the step 1 giving told us, right?
Yes.
Do we have an equal hypotenuse in each triangle?
Yes.
That's what the reflexive property told us in step 3. So once you're dealing with two right triangles and the legs are equal and the hypotenuse is equal, what can you say about the two triangles then,
They're
guys?
congruent.
By what theorem?
Hypotenuse leg congruence.
Okay, and what triangles were we going to write? Triangle
PQR.
PQR is congruent to
RSP.
RSP.
Yes.
By what theorem?
Hypotenuse leg congruence.
Hypotenuse leg. Hypotenuse leg theorem. Good. How you guys feel about this? Okay with it?
Yeah.
Yes.
It's a pretty easy.
Okay. You guys have everything you need right there?
Yeah.
Well,
When you guys are here, or if you decide to watch this again, make sure whoever the sub is, they pause so everybody can get everything down. If they can't read something, have them maybe read your notes or something like that, okay?
alrighty.
Alright, I did my best to construct a building here in this last example,
Wait,
guys.
Are we watching these in class?
Yeah, probably.
Okay.
It's up to them. I really don't care if they watch it on their Chromebooks or
Well, that's gonna be embarrassing.
so. Why?
We're gonna be in them.
Well, yeah. They're either gonna listen to it on their earbuds or in class. So
Hopefully not in class.
hopefully not in class.
Yeah.
Yeah.
Oh, come on, McKenna. This is the most you've talked in a class. It's pretty good, isn't it? Now you're really embarrassed.
I talk a lot in first hour.
Oh yeah.
Yeah.
All right. Help me with the vertices. Q,
W,
W,
X,
Y.
Y.
And there's a right angle too,
Two right
actually.
angles?
And that will, yeah.
Is there a vertice down here?
No.
9.
Let's call this vertice Z down here. Okay. Call that vertice Z. Okay, this is like a building. This is like a building. The gray part and the blue part represent the bottom base of the building, and there's like windows on top of this building that are triangular shaped. And there's a right angle going back this way, and a right angle going back this way. Now, guys, anytime we're talking about proving triangles, triangles make me cry, so I call them triangles. All right. Anytime we're talking about proving triangles congruent, there should be a big red flag that goes up when you see right triangles. You should automatically think hypotenuse leg, okay? Hypotenuse leg. All right, so let's see what we know here. It says two windows in a building. That's the two top parts up there are right triangles with WX equal to what, guys?
X, Y.
I'm going to put a tick mark here. WX equal to
X, Y.
XY. WX and XY, are they the legs or the hypotenuse?
Legs.
Legs. Hypotenuse.
The hypotenuse. They're opposite the right angle, aren't they?
Yeah.
Okay? It says prove that the triangles are congruent. All right. Well, let's roll.
More of these.
More of these. I'm sorry. Statement and reason. And I'm tired of a blue pen, so I'm going to go to this.
Should go purple.
Step one. What do we know right off the bat, guys?
Given X, Y, or WX equals X, Y.
WX equals or is congruent to XY, given to us. In a drawing, you also knew that these windows down here at angle Z, in other words, angle WZX and angle YZX, weren't they both right angles, guys?
Yeah.
Those were kind of given to you. That was in the diagram, right? Where it even said in the building they are what?
Right triangle.
Okay, so I'm going to say this. Angle, let's do it this way. XZW, all right? XZW is congruent to angle, let's go XZY. You okay with that, guys?
Yeah.
Yeah.
Okay, again, that's given to us, right?
Yeah.
But I want to show you something here quickly. To use hypotenuse leg, we have to have a right triangle. Is step 2 telling us we have a right triangle right here?
Yeah.
Yeah.
They're right angles, right?
Yes.
Okay, so this is telling us you got a right triangle situation. We have right triangles by that step right there. The given part right up here says WX is equal to XY. What are these called in that right triangle again? Legs or hypotenuse?
A hypotenuse.
These are equal, I'm going to abbreviate, equal HYP for equal hypotenuse in both triangles. Okay? So the part that we haven't established yet, anywhere in that drawing, is there a set of legs that are equal or congruent to each other?
Yeah.
Where to where?
X and Z.
X and Z are congruent to each other, right? And again, that X and Z, isn't that reflexive property appearing a lot now, guys?
Yeah.
So segment XZ is congruent to segment XZ, so we're going to say that that's true by reflexive property. But that's the part right there that shows that we have not an equal hypotenuse, but an equal pair of what? Equal pair of what?
Legs.
Okay? So on these 3 steps right up here, you know you have a right triangle. Both angles were 90 degrees. You know your hypotenuse is equal to each other because that was given to you. and you know that you have a pair of legs that are congruent to each other. So once you've established these three things, which two triangles can you prove congruent, and what's your reason for it?
X, Y, Z.
Okay, so let me write this down. Triangle XYZ.
Congruent triangle. X, Z, and W.
X.
WZ.
Oh shoot.
Yep, go this way, XWZ. So we're going to go to the hypotenuse. When you go XYZ, you go to the hypotenuse route first, don't you?
Yeah.
So go XYZ is going to be the same as XWZ. And what's your reasoning there, girls?
Hypotenuse leg.
Okay, step 4 would be the hypotenuse leg theorem. Okay? Very good. Very good. Okay, questions at all?
No.
All right, that worked out perfectly.